Hello. Today we're going to take a look at lesson 56, which is finding angles of rotation. To start right off the bat, whenever we're looking at angles of rotation, we will always have, I'll just use this piece down here as an example, our initial side that will always lay on the positive part of our x-axis, and then whatever kind of ray will give us our angle amount, that will be our terminal side. So those are two words that will go into all of these angles that we're looking at. And then if we have a positive rotation, that is going to be going counterclockwise, and the degree will just be how many ever degrees that would go. So our Cartesian coordinates of 90 degrees, 180, 270, and 360 are all pretty good indicators for us. Now, if we are over here looking at negative rotation, that is going to be the same type of concept. However, we're just going to be going clockwise instead. So if you want to think about it, we're going to be going towards 270 degrees, where normally that would be we would take a full 270 degrees in order to get to that point. So our first example, we're going to draw a couple angles in standard position. So I'm just going to give myself a nice little Cartesian kind of grid here. And what I'm going to do is my initial side will always lay on that positive x-axis, like I said. For part A, if I'm going to do 45 degrees, well, I know this straight up is 90 degrees, so 45 should be about halfway through, not about exactly halfway through, so that would be 45 degrees. If I'm going to do negative 225, so that means I need to go into the clockwise position. And again, here is my initial side. A good indicator here would be using that 180 degree mark. So I know I've gone negative 180 degrees at this point. And in order to get to negative 225, that would take an extra 45 degrees from that point. So just doing my best to cut that second quadrant in half. So this would be our negative 225 degrees. Now for this last one, 440 degrees, you might notice that this is more than or higher than the degree of our actual Cartesian coordinate system. So I know that that is 360 degrees all the way around. Now if I'm going to reach 440 degrees, I'm going to need to go another 80 degrees. So I'm going to do my best just to get just a little less than 90 degrees there. So that would be how we would do each of those. So we have just a positive angle, we have a negative angle, and we have an angle that's greater than 360 degrees. Okay. So the next concept in this lesson is taking a look at coterminal angles. Now, coterminal angles would be any type of angle that would share the same terminal side, which means that terminal side of the angle is just in the same position. So really, there are an infinite amount of coterminal angles that exist together, because we could always go around our Cartesian coordinate system like one more time. We can always add another 360 degrees or subtract another 360 degrees in order to get that same position. Now, the example they give here, so I know that this is 90 degrees. It's a pretty good indication point because we're pretty familiar with that. Now, if I were to go around 360 degrees, and then end up at 90 degrees. You notice I'm at the same point. However, I I'm at the same point, but those are considered different angles. So we have 90 degrees and we have 450 degrees. So those two angles, because they end up in the same position with that terminal side, those would be considered coterminal angles. So if we're going to find a positive and a negative coterminal angle for this first one of 43 degrees, I'm just going to take 360 because I know that's once all the way around, and I'm going to add that on to 43. So that'll be 403 degrees would be a positive one because they want one positive and one negative. And then I'm going to take 360 and I'm actually going to subtract 43 degrees if I'm going to get that negative one. And then I'll flip my signs. So 57. So that would be negative 317 degrees. Now, this one you might notice, well, if we get rid of 360 degrees, we are still positive. So if we wanted to find one of our negative coterminal angles, we're going to have to go further than that. So you could subtract 360 twice, or you could right off the bat subtract 720 if you want. But since subtracting 360 will still give me a positive angle that will be coterminal with this one, I'm going to use that method. So there's 5. So 155 degrees should be coterminal with 515. And then I'm going to take 360 minus 155, just like I did before. So we get 5, 0, 2, and that would be negative. So 155 and negative 205 should both be coterminal to 515 degrees. Okay, now our last concept here, talking about reference angles. So one thing I want to point out, besides the fact that of what they have on this slide, so I guess let me back up a little bit. So an angle with a measurement, this little guy right here, that's theta. That's a Greek symbol that we use to talk about different angles and things like that. So an angle measurement in standard position forms an acute angle with the x-axis. That would be a reference angle. So a reference angle will always be positive. It'll always be less than 90 degrees. So the 4 places that a reference angle could take place would be quadrant 1. So this would be our angle. It could end up in quadrant 2, where again we still have an acute angle. It could be, I'll switch colors. Quadrant 3 could be wider, but it's still acute. Or it could be in quadrant 4. So any of these are possibly reference angles. We'll take a look at how we would figure out which of those, depending on our angle, will be our reference angle. But for this example that they have up here, you notice they have this angle of rotation of 120 degrees. So they're starting here. Now, because we have this little piece right here, in order to get that angle over to 180, I guess would be kind of a good indicator. Our reference angle would be 60 degrees. So if we want to find the reference angle of 155, again, the actual angle that I'm looking for lays in the second quadrant with the x-axis. So I'll take 180 minus 155. So we'll get 5 to 25 degrees. Next. Now here you might notice how it goes past. So it goes past that 180 degree mark. However, I'm still going to use that 180 degrees as my reference because that part that I just highlighted in red, that will be my reference angle. So in order to do that, or to find out what that angle would be, I would take 240 minus 180. So we'll get a 0, 6, and 60 degrees. And one more. So even though we're going into the negative direction, remember that a reference angle will always be positive. So the angle itself that we're interested in is also our reference angle, only our reference angle will just be 20 degrees rather than a negative. Okay, so let's throw a little bit of trigonometry in here. Angles in standard position and reference angles can be used to find the value of trig functions for an angle with measurement theta. The distance r from a point Q with coordinates xy located on the terminal side of the angle to the origin is given by the square root of x squared plus y squared. Okay, so this might be a little bit confusing. However, I would like to point out sine will still be opposite hypotenuse, cosine will still be adjacent hypotenuse, tangent will be opposite over adjacent. However, it's all about where the right triangle is so that we can figure out what those values would be. So in this case, we're looking for our 6 trig functions with, we have this angle that's going over here, and we have our terminal side that's going at negative 12 or negative 512. Now, whatever quadrant you're in, you always want to drop a line straight down to the x-axis. Or I guess if it was into quadrant 3 or 4, you could go straight up. But it's always going to form this kind of right triangle. Now, theta, know that this is angle theta, but for our triangle, angle theta is going to go into that little corner. So it's going to go into the corner closest to the origin. Now we know that this distance here is negative 5. We know that this height is 12. If you are familiar with your Pythagorean triples, you would know that the hypotenuse is 13. You could also just figure that out by doing the Pythagorean theorem. So if I'm going to do sine of theta, cosine of theta, tangent of theta. Now if you guys are familiar with the unit circle as well, these will all make even more sense. Sine of theta, so from theta I'm going to go opposite hypotenuse, that's going to give me 12 over 13. Cosine, that's going to be adjacent hypotenuse, so I'll have negative 5 over 13. And then tangent is opposite over hypotenuse, or opposite over adjacent, sorry. So I have 12 over negative 5. Now let's throw our other 3 trig functions, cosecant, secant, and cotangent. So remember, those are just reciprocals of the 3 that we already have. So cosecant goes with sine, so that would just be 13 over 12. Cosine and secant are reciprocal of one another, so that would be 13 over negative 5. And then cotangent and tangent are reciprocal, so we'd have negative 5 over 12. That's what we have for our lesson today. If you have questions, feel free to reach out to me. Hope you guys have a great day.